Okay, last example. We're asked to sketch the graph of r equals 3 times cosine of 2 theta. Just to add a little clarity here, let's put the 2 theta in parentheses, so that way when you're punching things into the calculator, you don't accidentally just do the cosine of 1 or of 2 and then multiply that, whatever that result is, by whatever angle measure we're dealing with. This one we're going to do a bit more points than we had in the previous couple of examples. It's going to be kind of a more unique, interesting, and kind of cool graph, if you ask me. So we're going to do two separate tables. We'll just start with this first one here. We're going to have theta values of. So we got theta. We'll start with 0, pi over 6, pi over 4, pi over 3, pi over 2. Let's see, 2 pi over 3, 3 pi over 4, 5 pi over 6, and pi. So just kind of working through the top, the first half of the full circle. We're going to plug these into our equation. So we have, again, 3 times 2 times every one of these angles. Or, goodness gracious, let me try that sentence ago. 3 times the cosine of twice all of these angles. Now again, plug these into a calculator. So we'll do 3 times the cosine of 2 times 0. We end up getting a radius of 3. Again, just like in the previous example, I'm going to encourage us to draw these out. So facing in the direction of 0 radians, we're going to go 3 out for our radius. Pi over 6, if we plug that in, you end up with 1.5. These numbers are going to be nicer than some of the other examples. So again, facing this pi over 6 angle here, we're going to go 1.5 tick marks out. So a radius of 1.5. At pi over 4, so facing the direction of pi over 4, we got a radius of 0. That ends up being smack dab in the middle. Okay, I'm not doing a good job of what I was saying I was going to try to do. Connect your dots as you go. So this was our first point here, connecting to our second point, connecting to our third point. Again, try to make it a nice curve as you go. All right, if we plug in pi over 3, so if we're facing this direction here, plugging in pi over 3, we're going to get a value of negative 1.5. Remember, we're still facing in this pi over 3 direction. We're still facing that way, but this would be the positive direction for that angle. And then we're going to go in the negative direction. So we're going to go negative 1.5, so right about there. So we'll do negative 1.5 there, and we're going to connect that dot there. Moving on to pi over 2. If you plug that into your calculator, you get a radius of negative 3. So again, facing the pi over 2 angle, we're going to go, instead of the positive direction, we're going to go negative direction. We go down 3 in the negative direction for that one. So it's going to be there. We'll connect that dot. Next up, 2 pi over 3. You plug that in, we end up with negative 1.5 again. So again, visually, if we're facing 2 pi over 3, so if we're facing that direction, this would be the positive direction. We're going to go backwards from there. So we're going to go negative 1.5. So we're going to connect that, put a dot right about there. Oops, sorry. It was a little too far zoomed in. It wouldn't let me do that on my iPad. Plugging in 3 pi over 4, we're back at 0. So facing 3 pi over 4, turn kind of in that direction, but we have to go 0 out. So we're actually back right at the pole, right at that origin again. See, it kind of creates a leaf there, or a petal, if you will. 5 pi over 6. You plug that in, we end up with 1.5. So facing 5 pi over 6, we actually get to go 1.5 in that direction. We don't have to go backwards or anything, nothing fancy. There we go. And if you plug in pi, you end up with a value of 3. Right about there. So connecting those two, that was a bad one, let's try that again. Connecting those two, and that's where we're at. You can see it's got kind of some symmetry to it. Now folks, I'm going to create another table in a different color, and we're going to keep going around. We've made it really like halfway around our full circle. So that's not a straight line. Let's try that again. So we're going to keep going. We're going to do some more thetas. We're going to get some more r values. And we're going to kind of follow the same pattern. We'll go, next up would be 7 pi over 6. Then we'll do 5 pi over 4. Then 4 pi over 3. 3 pi over 2, 5 pi over 3, 7 pi over 4, 11 pi over 6, and 2 pi. Essentially, we're hitting all those angles that we saw in the unit circle. Again, plugging these in, 7 pi over 6, if you plug that in, you get a value of 1.5. So going in this 7 pi over 6 direction, we're going to go 1.5 out, so that's going to fall right there. And this is still part of the same graph. I'm using a different color just to kind of show where the change happens. But we're going to keep going, connecting that point to that point. 5 pi over 4, you plug that into the equation, you end up with 0. So that's back right at the pole, right at the origin again. 4 pi over 3, plugging that in, we get negative 1.5. There's a pattern that you're probably picking up here. Negative 1.5. So we're facing 4 pi over 3, so facing this direction here. But instead of going in this direction, which would be the positive direction for that angle, we're going to go in the opposite direction. We're going to go 1.5 that way. So we're going to be up here. And we'll keep connecting our dots as we go. Plugging in 3 pi over 2, we end up with a value of negative 3. So again, we got to work backwards. 3 pi over 2, this would be the positive direction because 3 pi over 2 is down there. Then we're going to go negative 3 in the opposite direction. So we'll go 3 up here. Connect, put a dot there. Connect your dots. 5 pi over 3, we get another value of negative 1.5. So again, if we're facing 5 pi over 3, so facing this direction, this would be positive direction. We're going to be going the opposite direction. We're going to go negative 1.5 in that direction. So it'll be right about there. At 7 pi over 4, we're back at 0. So even though we're like facing this direction here, we're going to go 0 away. We're back at that pole, right back at that origin again. I can't draw a nice curve right there. That's better. Moving on. At 11 pi over 6, you plug that in, we end up with a value of 1.5. So we're going to face in the direction of 11 pi over 6 and go 1.5 out. Connect those dots. And then plugging in 2 pi, we'd end up with a value of 3. So after we complete a full circle, we're back to where we started. It creates kind of this flower design. It's one of the prettier graphs you can get here.